Okay, hey everybody. So today we're doing 10.3, where we're still, let me get it to move, there we go, where we're still talking about uh, some more ways to display our data. Okay, so the first one we're going to talk about today are line graphs. So a line graph typically shows trends over time. Time is usually marked on the horizontal axis, and the variable being considered will be marked on the vertical axis. Consecutive data points are then connected by line segments. So here's an example of a line graph that's SANA's weight over 10 years. Line graphs typically depict continuous data versus the data we've looked at so far as discrete data. Okay, that's why we can go ahead and join them with a line. Think about the data we talked about last time with the president's ages. It really wouldn't make any sense to connect those dots if we, had a graph like this and we plotted them with dots. It wouldn't make any sense to connect one president was 47 when he was inaugurated and another one was 50. What would that mean if we connected the dots? But here we're saying, okay, this is the age in years down here. So a 2-year-old weighs close to 30 pounds. And as she gets older, say she's 2.5, it does make sense to see that, oh, her weight is also increasing. So here when she's 4, she's maybe actually that's where she's 3. Here's where she's 4. So when she's 3 years old, she's a little over 30 pounds. And she has a big growth spurt between the ages of 3 and 4. So it makes sense to connect those data because the data is continuous. And of course then discrete just means it's not continuous, right? It's separate individual points. Okay, so some abuses to watch for when you're looking at line graphs in particular, right, are changing the scale of the graph. So one thing if you're asked about, uh, a question about an abuse of a line graph, always look at the scales. Okay, so this one, it says these statistics presented are the exact same. So they came from the exact same histogram data, for example, but the graphs do not convey the same psychological message. So we're talking about the number of graduates of community college. This looks like, oh, the graduates were soaring, and then there was a steep decline. But over here, it looks like, there's not much change, and goes up a little, goes down a little, right? That's because look at this scale. Okay, this scale in between each number represents 10, right? 10 number of graduates. This one in between each number is 50 graduates. So on this one, they kind of zoomed out on the graph. Well, on this one, I guess they zoomed in on the graph. And on this one, they've zoomed out on the graph. So pay attention to your scale anytime you're looking at these graphs. Okay, a scatter plot. Sometimes a relationship between variables cannot be easily depicted by a broken line, so even by a broken line or any line. Well, okay, I'm going to take that back by saying any line, but by just connecting the dots. So a scatter plot may be used. For example, this scatter plot shows the relation between the number of hours studied and quiz scores. So the high score is a 10 and the lowest is a 1. So here we've got our hours studied and here's the score. So let's say you can make between a 1 and a 10. Okay, and this person didn't study at all and obviously made a 1. That's what you'd expect. He studied 1 hour, he made a 1. This guy studied 4 hours, still made a 1. But here's some people that studied 5 hours and they made everywhere from a 3, 4, 5, 6, 7. Okay, so notice it really wouldn't make sense to connect these dots. Again, it's not really continuous data. But we can add a trend line, right, that kind of follows the data. So a trend line is a line that closely fits the data and can be used to describe it and make predictions. For example, in this, we can see that it appears that the more hours you study, the higher grade you make. Now, some of you might be asking, oh my goodness, how did they determine to put that line there? It looks to me like maybe it should have been a little bit lower. And if we were in an actual statistics course, we would go through the steps to see how you can determine what they call the line of best fit. We're not going to do that. They're either going to be drawn in there for us, or we're going to draw what we think makes the most sense that goes through the middle of what we can, consider the most data. Okay, so if the trend line slopes up, we call it a positive association between the data. Okay, well, this says on the horizontal axis and on the vertical axis, but a positive association between the data. An increase in the value of the variable on the horizontal axis would predict an increase on the vertical axis. Likewise, if the trend line slopes down from left to right, we call that a negative association. So notice if it goes up, if the slope is positive, the association is positive. If the slope is negative, the association is negative. Sometimes there's no association at all. So you can say, oh, there's no way I could draw a line through there that kind of fits all of that data. Okay, so no prediction can be made based on the value of the other. Multiple line graphs may be used together to demonstrate different sets of data where comparisons may be made. Okay, so here's an example of a multiple line graph where we're not going to create them, but you could, just make comparisons, be able to answer questions on the difference in the data. Okay, here's something I need to pay attention to. So you may want to, pause this and read these yourself also. Choosing the right display is not always easy, and there may be more than one appropriate choice. So a pictograph, it's used to show data with pictures or symbols. A dot plot is used most often to show frequencies. Okay. Stem and leaf plots are used to show each value in a data set and to group values into intervals. Remember, an advantage of the stem and leaf plot is that we do not lose our individual data items. And of course, a disadvantage, it's just best with small sets of data. A bar graph is used to compare numbers of data items in grouped categories. Keep in mind the difference between a bar graph and a histogram. A histogram is a type of bar graph, right? But with a histogram, we have to have numerical data. A bar graph can compare categories. That's not numbers, right? Then there's the histogram, which is used to compare numbers of data items, typically grouped in intervals, and the order matters, and the bars have to touch. A circle graph is used to show the division of a whole into parts. So when you're comparing parts to the whole, you want to think about a circle graph. A percentage bar is used to show the division of a whole into parts. I don't even know if we're doing percentage bars. Okay, a line graph is used to show how data value changes over time, and it's normally used for continuous data. Scatter plot is used to show the relationship between two variables. Okay, all right, so keep all those in mind. Those are the different displays we've talked about and that you're going to be asked about, with the exception of a percentage bar. Okay, the data below gives the figures for the United States production of canned fruit from 2002 to 2009. Make a line graph for the data. Okay, so making a line graph, so I got to remember which chart is which again, this is going to be a huge advantage for when you take your test online. Okay, students always, if this were a question on our pencil paper test, you'd have to do what I'm just about to do. I'm going to have to create the entire graph. First of all, I've got to remember which one is a line graph. Okay, I've got to remember to include things like label both axes and give it a title and things like that. Online, it's going to be a multiple choice. Pick the line graph that, represents this data, and therefore you automatically know what a line graph looks like, because I think they're always all line graphs in those particular questions. So again, hopefully those kind of advantages will make up for the disadvantages in doing our tests online. Okay, so I'm creating a line graph. So I need a pen that writes first. So I need two axes. All right. If it's a line graph, remember your time is going to go on the horizontal axis, because they're usually used to represent what happens over time. So my years are from 2002 to 2009. 2, 3, 4, 5, 6, 7, 8, 9. So I'm just going to say this is 02, 03, right? Okay, so this is year. If we were actually creating it, we need to make sure we label our axis. All right, so this is cases in millions, 106, looks like my high. There's an 84, so maybe I'm gonna say 85, 90, 95, 100, 105, right? 85, 90, 95, 100, 105. I'm not going to be able to write sideways because I can't turn it sideways and write on it. Okay, cases. And don't forget, if we have something like in millions, we need to say that. All right, we also, our graph needs a title, right? So canned fruit production. Then you just go in and put a dot. In 2002, 106.5, so I need a dot here. 97.7, 84.4, 96.1, 101.5, 90.2, 88.5, and 90.8, and then you just connect the dots with a straight line, hopefully. Come on, with a straight line. And that's a line graph. All right? Then you could be asked all kinds of questions about it. Maybe over which years was canned fruit production in the United States increasing? Oh, well, between 04 and 06 it increased, and then again between 08 and 09 it increased. What was the lowest, what year did the lowest number of canned fruit be produced? Okay, in 2004, right? Just various questions like that. Erasing. Okay. Let's see what we have next. If the trend line has this equation, what y value would you expect to obtain when x has the value of 10? So sometimes when they're talking about the trend line on the scatter plots, they're going to, ask you questions about the specific trend line. What would the equation of the trend line be? So I need to remember from my college algebra, right, that whoops, sorry, didn't mean to move that down. It doesn't matter. Let me get my pen. Okay, that my equations align are y equals mx plus b and y minus y sub 1 equals m times x minus x sub 1. So remember these two equations from college algebra. So if they're asking you to find the trend line on this one, right, if you can see the y-intercept on your graph at an actual point where you don't have to guess, if the line goes between 1 and 2, you really can't guess, so that's 1.2 versus 1.3. So you might fall back on this one. But if it goes right through the intercept, the y-axis at 2, and then you can find the slope, you can just plug right in here, right? Otherwise, pick 2 points off of the trend line and plug in to this equation here. Find the slope using the 2 points and then plug in here. So a little bit of knowledge we need from college algebra. So a question like this, though, all it means is, oh, hey, here's my equation. What y value would you expect if you have an x value of 10? That's just plug in and let x be 10. And so if we let x be 10, then to do the math, so then I would expect my y value to be 17 if x is 10. Okay, so that's all those kinds of things are going to be asking you. Okay, how about this one? Consider an arithmetic sequence, okay, where the first term is 20 and it has a difference of 3. Plot this sequence as a scatter plot. Sketch a trend line and find an equation for the trend line you sketched. So a couple of ways that we can approach this. Okay, if the first term is 20, remember, and there's a difference of 3, then I can just take off 3 and get several points here. Okay, or I can remember, right? Remember that formula that we had for how to tell a term on an arithmetic sequence, right? It was what? The first term plus n minus 1 times the difference, where here n minus 1, I mean, not n minus 1, a sub 1, the first term is 20. And the difference is 3. Right? Okay. But this one's easy enough to plot these. So I could come over here. What did we wind up with? 1, 2, 3, 4, 5, 6, 7. Okay, so this would be when n is 1, right? When n is 2, when n is 3, when n is 7. I could also get those values by plugging in up here. And I see that my numbers go 2 to 20. So maybe, let's go by threes just because that's the room I have here. 3, 6, 9, 12, 15, 18, 21. Okay, and then I just come over here and plot. When n is 1, we've got 20. When n is 2, we had 17. Okay, when n is 3, we had 14. When n is 4, we had 11. Okay, when n is 5, I'm kind of getting off with my thing, but you get the idea. 8, when n is 6, it should be a 5. And when n is 7, we should have a 2. Okay, now this one, I wanted to do this one in particular just to remind us about what this means about being an arithmetic sequence, blah, 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 and how to get those values. But I could have been given any data, and I may have had, when I got through it, I might have had some dots like this. You just plot the dots, right, of your data. And then you would draw kind of a line, if I was doing this with these red dots, that goes, through my data. I'm going to erase that right quick to not. This one, I don't even really have a trend line. I have the actual line just because of the data that we're given. So here it is as a scatter plot. If I'm sketching the trend line, I would just go right, hopefully, through the points and find an equation for the trend line you sketched. Okay, so here's what I was saying earlier. This one, I don't have the y-intercept. However, since it is a definite linear equation, I know that really it's going to go through up here at 23, right? Since if I work backwards, I'm adding 3 each time. But let's say that I don't know that. Let's say, we had all those dots, those red dots, and I drew a trend line kind of going through there. I would need to pick 2 points, okay? So for this one, let's just use the 1 and the 20 and the 2 and the 17, right? So this is basically my x, y. And so if I'm trying to find the slope between these 2 points, okay, subtract my y's, subtract my x's, and voila, we get -3, which again, oh yeah, just simply because this was an arithmetic sequence with a difference of 3, I should have known that. But again, we're going through, what if you're just given some data points? You can take 2 points, you can find the slope of the line. And then you can plug in that formula we were just talking about. Y minus, let's just use this first point. I can use either one, right? Y minus my y coordinate, and then m times x minus my x coordinate. So distribute that -3 over there. I get -3x plus 3, and then solve for y, add 20. So -3x plus 23. Oh yeah, and look, there's that y-intercept we said we knew simply because this is actually, a line. that I knew that. Okay. All right, that finishes up 10.3. I'll see you next time for 10.4.